Cool. Welcome, Edo. You are the founder and CEO of Pinecone. Pinecone develops a vector database that makes it easy to connect company data with generative AI models. The company was started in 2019. You've raised 138 million in VC money, at least according to good old trusted Crunchbase, including 100 million Series B that was just announced. Congratulations on that, and welcome. So I would love to start with a bunch of definitions. We all in a moment where we're trying to understand what's going on in generative AI, and there's like all these terms that are sort of like flying around that I think most of us are trying to understand. So I'd love to start with vector embeddings. What are they, and what do you need them? Yes, this is the educational part.
How about now? Yay. All right. So when you look at the deep learning models, they are mathematical objects. They're number crunching machines. And in fact, the information that propagates between layer to layer or within the network is always a set of numbers. It's just that. There is no other way to propagate anything inside a neural net other than that. In fact, that's exactly the same thing that's happening in your brain, say in your visual cortex or in your auditory cortex or in any other parts of your brain. One process communicates with the other as a set of activations of neurons, right? They either fire or they don't. That's a set of numbers, right? So that's the way neural nets and AI in general represents data. That set of numbers is called a vector or a vector embedding. The embedding is a mathematical term of that refers to like placing one object in another space. So taking an image, which is in pixel space, and putting it in another space, which is the high dimensional like number array space, in a way that somehow keeps some of the representation of it. So that's the embedding. The vector is the array of number, and the embedding is the translation kind of preservation property.
And vectors help you understand whether there's similarity or not between concepts. Is that the right way to think about it?
Correct. So in the same way that you would see somebody that you know, right, and your visual cortex would process the face, and then with your temporal lobes, you would, access the kind of your face data, store in your brain and figure, oh, that's my cousin, right? That's happening in the vector embedding space. That's happening with the similarity search. That's happening with like a mechanism that looks a lot more like memory than it looks like processing like a neural net.
So let's say I have video data, audio data, text data. So if I understand correctly, I need to translate this into numbers to fit it into a machine learning model, an AI model. How do I do that? How do I take like video and translate that into numbers?
So we can talk about the mechanics of how to do it, which is maybe the less interesting thing because, the less technically inclined of you don't care, and the more technically inclined of you can figure it out. If you zoom out, though, the interesting part of it is that I think there is a significant shift in the way that people think about these building these smart AI systems, and they don't try to fit the data into the model as much as give the model access to the right data when it's doing the inference, right? And so, in the same, I gave this example several times. So, but like if you study medicine, right, you already go into medical school knowing English, and then you study like a body of knowledge. You study medicine. You don't study medical English. Like you read a book and you then know medicine and then you speak about it because you know how to speak, right? You don't become a doctor by just doing the rounds for 10 years and then you know enough, you know how to sound like a doctor. So uh, you know that's the answer in some sense. You don't fit it. You allow the model to access external memory and use it correctly. And you give it the right data. So if you wanted to be a doctor, you give it medical knowledge. If you wanted to use videos, you give it video data.
And that is vector and vector embeddings, and that leads us to vector databases. So we'll talk about Pinecone in a second, but what is a vector database in that context?
A vector database is the infrastructure that supports that long-term memory, right? So if you have a very small amount of data, you can fit on the machine and like you can kind of play around with it. That already is becoming almost unnecessary with these larger contexts and so on. But when you have millions or billions of documents or images and so on, you really have to have a very specialized system to be able to do this, cost effectively, low latency, high, persistence and so on. You really have to start thinking about things in a fundamental way and not, just about the data.
And for anybody that spends time in the MLOps world, in the last couple of years, before vector databases became a thing that everybody's talking about, like the concept of storing stuff that would be fed into machine learning models, people heard the term maybe feature store. Is that completely different? Is that part of the same family? How would you think about it?
Yes.
No,
I'm just kidding. No, it's a completely different thing, right? Feature stores are used mainly either for marshaling data into training or using real-time features for objects that change very frequently, right? So like if I'm a user and I just clicked on something, maybe you want to incorporate that last feature that just happened a second ago in my next classification, in my next action or something. Vector databases are completely different. It's really about this long-term memory, about these billions of embeddings of documents or images and so on, and making them available to large language models or these other multimodal models and so on, where they operate more like parts of your brain than like a feature store.
Okay, fantastic. Maybe one last concept, and thank you for explaining all of this so clearly. Semantic search is something that, again, people hear a bunch. What does that mean?
So semantic just means by meaning, and search means search. Traditional search is keyword based. Not because keyword search is that great, but just because we have great mechanism to run it at scale and it's very efficient. Keyword search is a pretty old technique. In fact, books had inverted indexes in the backs of them. They're even called an index. They've had them for a while. In fact, you had indexes in books before we had print. So that's a pretty old, before we had print in the West. The Chinese were printing well before the Gutenberg Bibles were even thought of. So. But anyway, it's like early 1200s at least. It's so keyword search existed for a while. Great technique, works great for Google, works great in other places. Doesn't work when you want to search something by meaning, right? When you remember a conversation that you had, I don't know if you've ever searched your inbox for an email you know for a fact you read, right? And the only way to do it is try to like hack the search system to figure out what word was there that I didn't use in another email. Like you try to like backwards engineer the crappy search. With semantic search, the whole idea is that you know what it means. You should be able to search by the meaning in free text, and the match would not be because like 3 words matched and they're next to each other, but rather the meaning is similar, and so I can retrieve that. And again, that looks a lot more like how humans remember things and not like how inverted keyword lookup stores look like.
Okay, so all of this is a wonderful, hopefully, intro into Pinecone and what Pinecone does. Tell us about the company, the history, maybe your background, how you came to start this company, especially because you started it, I believe, in 2019, which was, uh, you know, well in advance of like this whole craziness right now.
So yeah, so I did my PhD in theoretical machine learning and big data algorithms, and my postdoc in applied math. And
That was
already,
at Yale, right?
yes, um, and already then I was working on high dimensional geometry and functional analysis and kind of the foundational basis of machine learning. And I was always drawn into this like search uh, problem because it seems like especially gnarly. I then did two internships at Google on that topic. I joined Yahoo as a scientist. I became an adjunct professor in Tel Aviv University. And through this entire time, I kept like publishing and working in industry on infrastructure for big data and for machine learning. Stayed at Yahoo for about 7 years, which moved me back to New York after like a short stint in Israel. And then in 2016, Swami Shiva Subramanian, who now runs all databases and AI services in AWS. Back then, he wasn't a VP yet; he was only a director. Uh, but he called me up and he said, "Hey, we're starting this AI thing in AWS. Do you want to come?" And I said, "Okay, who's we?" And he said, "Me and Alex." It was like Alex Mola, who was I don't know if you know him. He's like a look him up. Very and yeah, that was like a journey I couldn't resist. Like come to AWS and basically build SageMaker and all these other great services out of
Excuse me, there must
AWS.
be like thousands of people now, right?
What?
How big
Yeah,
is the
yeah.
group?
It's several thousands now. Yeah. But you know, I'm saying this. I'm kind of recounting the whole story because throughout that time, vector search and vector representations and embeddings and that kind of basic concept kept getting more, gradually more and more traction. All the time, more and more people kind of understood what it does and what's happening with it. Um, and then at some point, like the BERT embeddings, kind of the transformer models kicked in, and then there was a big spike in understanding. And then that's it. In 2019, in some sense, I felt like that was the right time. I felt like it was going to get us about 2 years to kind of build the right kind of infrastructure correctly. Um, and we kind of timed it correctly. And so this is what happened. We didn't, by the way, foresee any of this chat GPT thing happening. We knew it would keep growing, but that I think completely took everybody by surprise, including us.
Yeah, so I can only imagine how wild a time it must have been at Pinecone over the last the last few months.
Yeah.
Um, and so vector databases are becoming very much a central part of what seems to be emerging as the AI stack. So, when people talk about like, okay, like how do you do this whole thing? Vector database is like the term that everybody comes back to. Um, what does a stack look like, I guess, based on what you see customers do, this vector database, this lang chain, this like different models, like how does that all fit? What does that look like now?
Yeah. So there is I mean, it depends what you call like. So I'll focus very narrowly on the large language model stack. Um, of course, they're the model themselves. There are vector databases. There are libraries that connect them in all sorts of different ways, like Llama Index and LangChain and others. Um, there are, I think there are a lot of connective services, but um, I think we're going to see an emergence of agents in some form or another. I think that's still very
Do you want to
new.
briefly explain what agents are?
So agents are these recursive pieces of software. I don't even know how to define them in that. It's sort of like this like life hack on large language models. It's like, how do you use these large language models, enable, like let them use tools like, search or different APIs and so on, and then use their own answers to somehow feed back into like an input and try to accomplish very complicated tasks, right? So it's not like a one-time, you know, uh, it's not like a one-time prompt. Like, if you want to get in shape, right? I mean, that's a plan. You need to fit into a schedule. You have to find a gym. You have to whatever. There's like a sequence of things you need to do, and you can research every one of them separately. And you might think, as a human, it wouldn't be like a language generation thing. It would be like you sit there and plan it. So these agents are now coming up as like uh, this new paradigm of building more complex sequences and plans. Yeah, I put an asterisk next to that. I think this will shake up some surprising ways in the next few months. We'll see.
Great. Let's talk about some of the use cases that you've seen with Pinecone. Maybe if you can use some customer examples, but as I was prepping for this, search generation, security, personalization, data management, like pick a handful of those and sort of double click on how people use Pinecone.
Yeah. So first of all, it's one of them is an obvious semantic search. Like people are literally just reinventing their own search stack. I don't know whoever try to truly optimize like an elastic search cluster. I mean, and like after 3 weeks, wanted to throw your keyboard out the window, right? So with large language models, you know, that a lot of that is sidestepped and improved in a significant way, and people use Pinecone to just drive the backend search and storage based on these vector embeddings rather than keywords. But that's very obvious and immediate. Nowadays, we see a huge uh, uh, wave of people using us to create context for ChatGPT like and Bard like uh, applications. So call them like chat as a whole, but chat is very general. It could be customer service. It could be you name it. But there's a very wide variety of use cases, from like anomaly detection to like one of my favorite applications is somebody built a face detection for cows, and we're like, I didn't even know you can face detect cows. I didn't even. I grew up in a seat. I didn't even think cows look different. So, I mean, but then I told it to a farmer and they got deeply offended. So, I'm probably offending some people here. I apologize.
Um, Maybe that's related to the cows question, but one really important part of vector databases is because they are the long-term memory, as you were saying, um, they are a very important tool against that problem of hallucination that people talk about a lot. Is that the right way to think about it?
100%. In fact, I was looking at experiments today from one of our teams, and we literally measure reduction in hallucination as one of the core metrics that we try to drive. So 100%. Like, and by the way, I mean it's almost like uh, obvious. Like if I ask you a question for which you don't know the answer, right? But I compel you to say something anyway, you're gonna make something up, right? But if I give you the right context, you can answer a lot more accurately. And that's exactly what's happening. And so the question is, can we retrieve the right context out of which an informative answer can come out, right? And so, in some sense, it's obvious that should happen. It's harder to actually get the whole thing to cascade correctly and to work measurably well.
So very practically, I'm a company. I want to deploy GPT-4 in the enterprise, but for mission critical application like chat, where I don't want it to like say stupid stuff to my customers, I would I would use Pinecone. I would put basically my source of truth. This is like the history of customer conversations into Pinecone, and then how do I make GPT go fetch the
So
information into Pinecone?
in when when you want to query, when you have a question, say, or like some prompt, right? You want to add context to it. The way you would do it is you take that prompt, you would embed it with some language model. Search in Pinecone for the context, which could be maybe the top, I don't know, 100 relevant documents or 100 relevant parts of sentences or paragraphs, and put that back with the context. Say, this is the prompt, and here is more context out of which you can give an answer. And that ends up being even when you do that relatively crudely, because there's like you can do what I said right now in like 1,000 different ways. You can ask which language model should I use, and how should I parse the data, and how should I chunk it, and why should I put it, and what's the order. Like you can play with it in a million different ways. But even if you do it relatively naively, that already gives you a huge bump in accuracy or reduction in hallucination, depending on how you want to measure it.
Great. I have so many other questions, but let me pick one or two, and then I'll open up to people. The hands are already raising. Um, let's see. Look, I'm a VC. I'm always interested in that part as well. Let's talk about go-to-market. Like, how you building the company? How you finding customers? How you selling to them?
So we started Pinecone, or I started Pinecone uh, as a managed service because I'm a really big believer in kind of the buyer-driven journey, right? I think in the modern world, like nobody wants to like if you want to use some technology, the last thing you want to do is like send an email and wait for 3 days. Like that sounds very unnatural. You want to use it immediately, right? You want to, and if it's great, you want to just start using it and forget it, like be happy and move on. So we really built the whole company about the self-serve journey, right? Today you can start with Pinecone now, be like run some example in 5 minutes, build like a demo app in like 2 hours, integrate with some like kind of like a micro POC for your team in a day, and like in a week be in production, and never talk to us once if you choose not to, right? Some companies today, very large, larger companies, tend to also want to talk to us, and so we're now building a sales team that is happy and willing to engage and help and so on. But it's more about assisting in the journey if that's wanted, or kind of standing, like not being in the way when we're not wanted.
All right. Last question from me. I'm curious about the space in general. It's become, what feels like a very sort of rich and vibrant slash competitive space. Very, very.
What has become
The space, the vector database space, and I'm curious, less in the context as a prompt to bad math competitors, but more as a way for us to understand the space. Like all those companies that are vector databases now, are they like very different approaches, or you all sort of going in the same direction, and it's more of an execution kind of play to win the market?
Yeah, I'll try not to badmouth anyone. I'll just say about stuff about us, and you can extrapolate.
Or feel free. This is recorded, but like feel free.
Yeah. It's only YouTube will know about this. Yeah, I mean, look, I mean, I'll tell you what's driving me and my team, okay? And first of all, it's the technology itself, right? I mean, this is the internals of these databases are actually incredibly complicated numerical data structures, and really it's very cutting edge technology, both on the distributed system, the data management, the persistence. We had to rebuild like our own object storage that, like basically had to build the whole stack from the numerical indexes to the object persistence to the distributed data to the to the query planner, the whole thing. So as a systems and algorithms person, Pinecone is a fascinating place to be, and I can tell you that we are far and away better in terms of efficiency of running this service at scale and its stability, and we are just getting started. Like there's so much to come. Okay, so that's number one. Uh, and the second thing is, having spent a lot of time in AWS, I got indoctrinated a little bit to be, customer obsessed rather than competitor obsessed. And we are delighted and happy that we have a lot of very demanding and enthusiastic customers. And so we're very focused on what they want and rather than what our competition is doing.
Yeah, and by the way, just as a last word, I was as I was prepping for this, I read somewhere that you guys got like 10K signups a day.
Yeah.
That's insane. Anyway, that's so exciting. All right, very cool. I said I would open up to questions. Maybe somebody who has not asked a question first.
Thanks for the comments, Edo. Very enlightening. Just wondering, since you've been on both sides of the world, like you were in AWS and it's big tech, you've seen how it works, and now you're in the startup side of things, super fast-paced, constantly innovating. I was wondering what your thoughts are on how the hyperscalers are sort of looking at this, i.e., why do you think this is something that they've not done yet? And if you think that this is something that they would do, how far away do you think they are from, reaching where you are right now?
I know for a fact they're looking at it. I know for a fact they will have something. How fast it will take them to get where we are today, I have no idea. I mean, it'll take time, right? But we're running pretty fast, so I think it'll be interesting to see if they ever get to be more advanced than we are at the same time. That's the interesting question to me. I mean, whether it'll take them a year or 2 or 3 to catch up to where we are today, I don't know. That won't be surprising to me.
Hi, Edo. Thanks for your talk. I guess this is more from like a recommender system application perspective. I was wondering if you had any practical tips for like quality monitoring on embeddings, and if there are any plans in the Pinecone roadmap to build that into the service.
So there's a company called Snorkel. I don't know if you heard about them. I mean, maybe we can take this offline. I mean, I think we can dive deep into like what recommender system people do, but there's a ton. I mean, it really depends on what you're doing. So I mean, there are like 7,000 flavors of recommender systems. So I'm happy to chat about it though.
Hi, love the work you're doing. I'm curious, you mentioned agents. So with those developing rapidly, you said next couple of months or so, would something like prompt engineering or the role of a prompt engineer just disappear in the next, I don't know, year or so?
I mean, I don't, a lot of people believe that prompt engineering is incredibly crucial. I don't necessarily buy into that. I don't know if you remember, but people like thought that like, you know, query building for Google would be a profession too, right? And that didn't quite take off. So I don't know. I mean, I think this is it's a deficiency of the technology because it's very nascent. It's incredibly powerful, but still quite crude. And so, yeah, I mean, you kind of have to work around its sharp edges, and not everybody knows how to do this today. But it's like a basic limitation of the technology. It's not, I think, something. I don't know if it's gonna stick around.
Cool. All right. So the careers of all the would-be prompt engineers was squashed. That feels actually like a wonderful place to live it. Thank you so much. This was super interesting. It's really incredible how just Pinecone has just vaulted to the forefront of just consciousness in this world of generative AI. So congratulations on all the incredible work that you guys have been doing.
Thank you.